Okay, let's talk about inter-process communication. This is the other API, the API we will discuss now. Let's talk generally about API types. WinDriver works in both user mode and kernel mode. The user mode API is called high-level API, and the low-level API is called, the kernel mode API is called low-level API. In the past, we offered only low-level API, and then we started to add high-level APIs that are equivalent. The high-level APIs are more sophisticated, easier to work with, and we keep updating them. So we recommend working only with high-level APIs and not with low-level APIs. They are easier to troubleshoot, to debug, to operate, or to code. So we recommend working with them. Another thing we need to pay attention is the function name. So we have WinDriver function starts with WD something. So WDC is for PCI, WDU is for USB, and WDS is for server API. Okay, for every other name, the function is a low-level API function. IPC is as I said, inter-process communication. It allows several WinDriver-based user applications to send and receive user-defined messages. What are we trying to solve here? Okay, so you have a device and you have several processes or applications you want to access and read and write to the device. And we all know this is pretty complicated. You need to create access mechanisms. You need to make sure that there is no resource overlap. You need to make sure that one process or application is not writing on another's memory segments or performing operations, and to prevent collisions. So what we offer is inter-process communication that allows one process to connect to the device, and the other process to send messages to the device, get informed when an interrupt is raised, and we will see more implications of this API. But if you're creating a more complex systems and you need your device to perform for more than one application, we recommend working with IPC. Because again, programming a driver with multiple accesses for a device is a headache, and there are a lot of things that can go wrong. But once this is your architecture, or with other processes that are trying to access via one process, it can reduce the complexity of this of the architecture. I just want to add a note. IPC requires a special API, and WDS, which is the server, is also another API that is required in the demo I will present. So if you are interested in IPC and you already have a license, contact our sales team and ask for a quote, because not every license, the evaluation licenses have this feature already included, but other regular licenses does not have it automatically. It needs to be purchased in addition to your subscription. So the first thing, maybe the most basic thing IPC API offers is to divide or let's say create groups of the applications, and you can manage the communication in these groups. Okay, so we have a multicast, a message that is sent to all the processes that are registered with the same group ID, a subgroup. Okay, if you have a group and you have also a subgroup, so send only to the subgroup, and a unicast, that message that is sent to one specific process. Let's have a demo. This one, hope it will go smoother than the previous one. Okay, so this tool is PCI Diag. PCI Diag is WinDriver utility. Let's do it like this. It enables an instant access to your device with no need to do anything, no coding needed. Second, let's put it here, and another one here. Okay. This utility can be found in the utility folder or in the samples C folder. I'll enlarge the text so it can be clearer. And what we have here is 3 different applications that are running simultaneously. Now, I want to manage the IPC here. I want to register the process into subgroup 1. This is another application, and I want to manage IPC and register it also to group 1. And if I want to find current registered group processes, okay, so I have 1 and I have 2. And I want to add another one. So manage IPC, register process to subgroup 1. Okay, I see that I have 2 processes in the current group, 1 and 2. Okay. Now let's send a message. Let's send a message between, let's send a multicast, send a message to all the processes in the current group. So enter the message ID. 1 and 2 are already captured. So let's say 1, 2, 1, 2. And the message, okay. So I've sent this message 1, 2, 1, 2, and I said dead beef as the data. And I can see in the other applications that are in this group ID that a message was received. Okay, 1, 2, 1, 2, dead beef from process 1. Okay, it's essentially the same message saying that we got a notice. So if we're talking about the most basic operation of IPC, so this is it. Adding a process or application or process to the group and send a message to it. Unicast, I can, this was a multicast, I can send the unicast. We will see it on our code. And later we will create a shared interrupt and see what happens when we raise an interrupt. Okay, so this was one example of the group ID and sending a multicast. Again, you can do this yourself. Go to WinDriver's folder, samples, C PCI Diag or utility PCI Diag, open several applications. You don't need to code anything and do exactly like I did and see that it works. Okay, now this is let's say this was pretty straightforward. Okay, the demo. What I want to go over is the functions. Now, not all the functions because it may be too much, but generally, what stands behind this simple operation, which can seem superficial, but a lot of things going behind it. So what allowed us to create, to register the process in the group is WDS, the server API, IPC register. This is it's a signature. It is available on our documentation. We have the process name, the group ID, the subgroup ID, of course, the action. The action actually enumerates between the unicast and the multicast, okay? But the more interesting or the most important one is this one, is the IPC message RX handler. So what this does, what this pfunc does, it's a user mode IPC message handler callback functions, which will be called when a message was received by WinDriver from a different process. So basically, this pfunc is what happens when this message is received. Okay, this is for you to configure, to code, to implement your logic. We will review the code, okay, later. But just remember, there is a lot of things you can add to this functionality in order to perform the way you want. And we also have the P data, which is the data for the user mode IPC message handler callback routine. We will overview the code later. Okay, so we saw a very basic operation of creating groups and sending a message within the group. Now we want to raise an interrupt. Okay, we know that raising an interrupt is an important feature when we're talking about PCI devices. And once we have a group that only one application is connected to the device, we want to be able to perform operations with the other applications that are not connected to the device that includes raising an interrupt. Okay, so what will happen is we will raise an interrupt using the application that is connected to the device, and we'll create a callback automatically. The interrupt will raise at the other applications, and we can write a callback and other functions. Let's say send a unicast to the process if we want to send something, to perform something with the device. So we talked about the IPC register, and then what we need to do is send a pointer to that function as an argument to WDS shared int enable. Okay. After we've done that, we need to disable the shared interrupt, and this is done using these two functions. Let's see a demo. Okay. Let's close everything because we can, and open a new PCI diag. Okay. Okay, so this is a virtual machine with a virtual device. It's called Edu. I don't know if you're familiar with it, but I have the option to raise an interrupt with this machine. So I want to find and open a PCI device. I'm entering the number. Okay, and I can see my device details. Again, if you already used WinDriver, this is pretty straightforward and familiar to you. I can see I have an interrupt here. Let's see the interrupt type. And now let's raise an interrupt without doing anything, just raising an interrupt, not registering it to a group ID or send messages, just to see that raising the interrupt works. So before I raise the interrupt, I want to listen to the interrupt. So let's enable the device interrupt. We had a full webinar about how this works, WDC int enable. So if you're not familiar with it, I recommend watching it. So now we are listening to interrupts. And now comes the part where you need to be familiar with your device, what raises its interrupt. So for my device is writing to offset 60. So I want to write to my device, 5, write to active address space. I choose offset 60, choose 1, and I have an interrupt, okay, that was raised. This is the message printed, got interrupt number 1, got the message data, and everything seems fine. Okay, now let's create a group and register this application while the device is open to a group. Okay. Want to register it to subgroup 1. And now I want to add this application with no device open to my group. Okay, this one is not connected to my device. This application, I want to add it to group 1. Great. So I have 2 applications that are registered to subgroup 1. And now I want to raise an interrupt here in my application that is connected to the device and have a signal here that says an interrupt was raised. How can I do that? Let's enable a shared interrupt via IPC. Group ID 1, and I have it enabled. I need to enable the shared interrupt also here. Okay, now the whole group is open for receiving interrupt messages. Now I need to raise the interrupt. Write to inactive, enter offset, enter data, and here I have it. I have another interrupt I received, number 2. Receive an IPC message that one of the processes raised an interrupt, shared interrupt via IPC arrived. You can see both of the messages regarding the interrupt was raised. Okay, so this is how to manage shared interrupt when only one application or process are connected to the device, and you can add functionalities to it. Let's see what it means. Let's go back to the presentation. Okay. So here we have the WDS shared int enable. Function. Again, this is its signature. It is available on our documentation. This function includes the process name, the group ID, subgroup ID, the DW action, which we went over. And here, this is your place to enter the callback, the what happens after the interrupt is raised. Okay, just to, you know what, let's open the code, see how it looks. Let's open Visual Studio, PCI diag. Again, all of this is available on your computer if you've downloaded WinDriver. So you can just open the code exactly like I'm doing right now and see for yourself. Let's go to CMake target views, shared, and everything is here. WDS. Okay, so this is our function, WDS shared int enable, called when the sample pfunc the pfunc. Okay, this one. IPC shared interrupt message event callback. This will cause the shared interrupt to invoke both this callback and the callback pass to WDS IPC register. So as I said, we have different parameters here. The first one is process name string, the group ID. Default, everything is defined already above it, the subgroup ID, the action, which tells us if it's a unicast or a multicast, you can see here, as I said, and the callback. Now, the callback is the most interesting part because this is the p-func. This is exactly what defines what will happen after the interrupt is raised. Okay. So in this case, the callback or what happens after the interrupt is raised is simply printing the shared interrupt via IPC arrived, the message ID, the message data, and that's it. But you can add functionality here, the callback. Whatever happens or needs to happen after interrupt is raised should be defined right here. So you have a lot of room to add functionalities, to add anything you want to to happen after the interrupt is raised. This is where it takes place. Okay, and this is the code. Again, available for everyone who downloaded WinDriver. Okay, another thing I want us to cover when talking about IPC is the buffer sharing between multiple processes. So, as I said, one of the processes is connected to the device and it transfers data, and it can be allocated during a DMA session or just a simple kernel buffer. So the first thing that needs to happen is to allocate a buffer, DMA or kernel buffer. This is process one. Then we need to get the global handle, okay, to retrieve the global handle of the buffer. This is also process one is doing using WDS shared buff get global handle. It needs to share the global handle, okay, using a unicast, a subgroup, or multicast. We saw how these messages are sent. And then the other process is receiving the handle and is able to access the device, okay, and the data, the buffer, and everything. So you can do it with the device itself, but you can also, I will demonstrate it with the memory, okay? How can we share this buffer, not to a device, but to a memory section. Okay, so let's open. Let's start from scratch. One and two. Okay. I want to manage IPC. Add to subgroup one, manage IPC. Okay, both of the applications or processes are registered to the same group. Now I want to choose number 10, allocate a shared kernel buffer with all processes in current group. Okay, so here I go, choose the size, say 5,000. And as you can see, successful kernel buffer allocation, I got the user address. The size is predefined in the code, so we will see that. But also, the other application or process received the handle, and they have the addresses, the kernel address and the user address, and they are able to access this buffer. So again, it can be done using a regular kernel buffer or while using a DMA. Now, if you think of it, DMA or programming a DMA with more than one application can be quite a headache. Think that one process is performing the DMA, takes everything to a buffer, and then you have other processes that can access the DMA memory. Instead of extracting the DMA data to another memory section, and then they need to access it. So no, here you can perform it using DMA. I will show it next. But this can improve speed. It can make the development easier, the architecture easier. So I really recommend trying it yourself. Let's see how it works. Okay, let's open the PCI diag code. Okay. So I have this IPC curve alloc and share. Okay, as we see that this is the message that was printed after the memory was allocated. Okay, the buffer was allocated. We can see it here. WDS shared buffer alloc is maybe the most important function in this routine, because it is essentially allocating the shared buffer. And again, you can add the parameters here. The handle is being transferred here. Okay, if we talk about, so this is the size of the buffer that is allocated. As I said, it's predefined. It decides the bit mask, if it's contiguous, non-contiguous, if it's one segment or more, and of course a pointer to the buffer. And you can see here again the prints and other functionalities that can be added here. Okay. Okay. So let's go back and continue with the presentation. As I said, you can do the same thing with the DMA. Okay. If I'll go to my groups, wait a second. Let's say open the device. Okay, I want to allocate a free memory for DMA. Allocate the contiguous memory, say for 10,000. Choose 0 as a default. I can see that I have the allocation done correctly. I have the user address, the physical address, the size, everything looks good. And then I have an option to send the buffer through IPC to all group processes. So let's choose 4. And I can see that I got a DMA buffer in this section. So again, very easy. The code is running in the background. You can add, modify it, add your functionalities, and develop your driver with the complex functionalities with ease, relatively. Okay, I just want to see that I haven't missed anything. Let's go over here to the code. This is freeing the buffer. Okay, so this is important when we're talking about, just a second. We're talking about the functionalities, okay? About what are the data supposed to transfer. Okay, what is the type of the data that is being transferred? So here you need to add your own functionality if you added functionality. So in this case, if I choose one, it is go to menu SB alloc config, okay, which is expecting to receive a specific value, okay, a specific value. So you need to add your functionalities here in this section. I think we went through the more important functions in here. Okay. So this webinar was the first one about IPC and covering the 16.3. We have previous webinars. Okay, they were all uploaded and added to YouTube and to our video section on our website. We had webinars about predefined action flow, DMA, debugging, as I said, interrupt handler and IPC, predefined action, test sign mode. We will add this video to our library. So I recommend going over and watching it. We have blog posts on our website on different matters and subjects. And we have the WinDriver Academy, which includes short videos about specific functionalities of WinDriver, performing DMA, overviewing USB and PCI, driver distribution, INF mechanism, and more and more. So I recommend visiting our academy under WinDriver's website and learn. Maybe there are a lot of things in WinDriver that are not known, and some functionalities are not being used, and you may benefit from it. So again, like IPC, discover more WinDriver functionalities. It can make your driver faster, the development process more pleasant and enhanced. So thanks again for everyone who listened. If you have any questions, feedbacks, anything, feel free to contact me here, Daniel B. at Django, and I'll be happy to help. Thank you.